This conference will now be
Okay,
recorded.
so this is one of the main reasons why SAP HANA is widely used in the analytics modules. Okay, so the columnar storage will make HANA a preferred database for all analytics domains like BW, HANA, sorry, BW before HANA. So generally, even for SAP Analytics Cloud, it's almost what are the SAP is designing its analytics solutions. So they're going with HANA as a database. The main reason is columnar storage. So what do you mean by this column storage? How it works? So what are the advantages of having a column storage? I can, if I generally speak in this way, HANA and Oracle are almost same when it comes to handling the OLTP operations. Okay, so they both almost give you the same level of performance when it comes to business applications. But when it comes to analytics, okay, modules, so the performance with HANA database is quite high when you compare with other databases. That's the reason BW, lot of companies, if you see the current world trend, like almost 85 to 90% of the companies which are using BW or before HANA is anyway HANA database, so which are using BW as a data warehousing and modeling solution. So they migrated to HANA database. The main reason is okay. So first thing, in-memory database two-tail. That's they are not the major reasons. The main reasons why this BW applications move to HANA database is because of column storage. So how this? So what is a column store database? So in general, any database you pick, just giving a basic overview. It can be it can be two types of databases. We have generally a row store database, and you can have a column store database. So all traditional databases like Oracle, DB2, okay, MS SQL, these all are row store databases, guys. HANA can handle both row and column. Okay. So what is a row store database? What is a columnar database? Just a minute. I'll just show you one image. Okay, if you select any table, if you select any table, guys, you see the output in this format, right? So I have a table with three columns: country, product, and sales. So this is how you see the data. So, so my question is it the same way we store the data in the database? Okay. So is it the same way we store in the disk? The answer is no. Okay, generally, guys, you know, right? Any database you take, the disk contains magnetic tapes. Data is stored in a magnetic tapes. Okay, these magnetic tapes contains a small memory locations, guys, where data will be stored. So magnetic tapes contain memory locations, and data will be stored in the memory location. If it is a row store database, one row data will be stored in one memory location. If it is a columnar database, one column store data will be stored in one memory location, one storage location, I can say. So if the same table, if it is a row store database, so India chocolate and 1000 will be. So this is a better diagram, This is better. Okay. So if you select this, so if it is a row store database, US alpha 1000. So this will be stored in one storage location, second row in the second storage, third row in the third storage. So how many rows you have? So data will be stored in that many locations. Okay, and if you go with a column store database, one column data will be stored in one storage location. It's like entire country column data at one storage location product. So in the same way, I can just try it like this. Hey guys, just a minute, please. I got an important call from company. Just 1 minute. Sandeep, Padma, can you hear me?
Yes, Satya.
Others, can you hear? Chandrasekhar, Padma.
Eh, Yes, yes, sir. I can.
Yeah, right, right. Actually, I got some production related error, so that's like an call which cannot be avoided. Okay, I'll come back. See you. Uh, so this is a table. Okay, so generally any database you take, it has go with a row store or a columnar. So if it is a row store database, one row will be stored in one storage location. Means you see the table in this format, but this is not the format which a data will be stored in a database, backend database. So data will be always stored in a different format. Okay, if it is a row store database, this is the format. Columnar state database, this is the format. Okay, so generally all the traditional databases like Oracle, DB2, MS SQL, they all are row store databases. But whereas HANA can handle both. Okay, it can handle both row store and column store database. It can have both row store tables and column store tables. Whenever we're choosing a table in SAP HANA, we can choose between a row store table and a column store table. Okay, clear. So generally, though you see the data in this format, the tabular format, but actual way the data gets stored is in this format in Oracle database. This is how the data will be stored. Okay.
Sir,
So
in column
what?
storage, data mismatch may happen.
Why mismatch?
I mean,
It
sometimes,
stores it stores an index.
suppose in that above example, UK has some other column connection. So anytime did it happen? Just I want to know.
Never, and that's a product design. If it goes wrong, so no company will buy it, right?
Okay,
So it never
carry on.
happens. They have got an index concept, so which will overcome that. I'll discuss it clearly later stage. So generally, guys, if you take a row store, if you take what are the major database operations? You all know what are the major database operations we have. Writing the data, okay, into the tables. So the major database operations are write operation. So writing new data into the tables. Second one is read operation. So reading the existing data present, just viewing the data. Delete operation, deleting the data, and then update operation where you change the data. It's like modify the data. So these are the four major database operations. Okay, delete and update, they are not so used frequently, but any company, write operation and read operation are very critical for a company, because whenever you perform any transaction on a company, for suppose you went to some website and you performed a transaction, you click on submit, what happens? This data has to be written into the database table, right? Whatever you enter in the transaction, so data has to be written into the database table. So means if you want your transaction to be quick, okay, if you want your transaction to be quick, so write operation should be quick in a database. Okay, same way if you take BI perspective, guys, for BI the end product is a report. If you take an ECC perspective, for ECC the end product is a transaction, right? A website where a web portal or a mobile application where transactions can happen. If you want your operations or transactions to be quick, so then write operation into the database should be quick. Simple formula. And for BI, if you take BI, if you take business intelligence into consideration, for BI, so the end product is a report. If any user come and click on that report, what happens? It will hit the underlying BI system. From BI system, it will hit the underlying database and read the data from database, right? Okay. So if you submit any transaction on web portal, it will through ECC, it will write the data into the database. If you want your transaction to be quick, write operation in the database should be quick. Same way, if we execute or if we click on any reports, it will hit through BI, it will start reading the data from database. There is no data loading. Data will read from the database and then it will be shown into the output. So if you want your reports to be quick, then read operation should be quick. So guys, I can say for OLTP systems, write operation is the most critical operation. For transaction platforms, write operation is the most critical operation, and for analytic applications, read operation is a highly critical operation. If you want your reports to be quick, read operation should be quick. So for us, the major operation is read operation always. Clear? So now, when you go with row store, guys, row store gives you better performance for a write operation. The row store gives you better performance for a write operation, means it is like a preferred database for OLTP systems. So row store is a preferred database type for OLTP systems, and column store gives you better performance with a read operation. And column store is a preferred database for OLAP systems. Okay, so clear now. So generally, row store gives you optimized performance for a write operation. So it is preferred database for an OLTP system or OLTP operation. Preferred database for OLTP operations. I don't say OLTP. And column store gives you better performance with a read operation. So that's why it is a preferred database for an OLTP operations and the BI related operations. Okay, column store database gives you better performance. Why and how? I'll show you. So I have a table here. For suppose I have a table, guys. I have a table like this. So it contains 4 rows and 3 columns. Okay, I take a simple example. For suppose you go to ECC, I have a sales table in ECC, guys. In a sales table, I got some 100 columns. Okay, in a sales table, we got some 100 columns, and data in that table is 1 million records. Repeat, so sales table containing 100 columns and 1 million records. If you store the table data in a row store database, okay, so data will be stored in 1 million locations, because 1 million records means 1 million storage locations straight away. Am I correct? Okay, if it is a row store database, okay, data will be stored, okay, one row data will be stored in one storage location. So if it is 1 million records in a table, so data will be stored in 1 million storage locations or 1 million memory chips. The same table data, if it is a column store database, the same table data will be stored in 100 storage locations, because it's containing only 100 columns. So in SAP, you don't find tables with more than 150 columns. It's always 100 to 150 columns. So means the same data will be stored in 150 locations. So guys, now tell me, so reading from 1 million locations is easier, or reading from 100 locations is easier? Simple formula is, so reading from 100 locations is quite quicker than reading data from 1 million storage locations. Okay, so generally from the disk. So that's the reason why the column store always gives you better what do we say, better performance, okay, with the read operation. Okay, and when it comes to write operation, for suppose I got a new record into this table, so something like okay, something like France chocolate and 5,000, that's the data. If it is a row store database, it will directly access a new storage location, it will directly access a new memory chip, and data will be stored there. If it is a column store database, it has to access country storage location and incorporate France there. It has to access product storage location and incorporate chocolate there. It has to access sales storage location and incorporate 5,000 there, which will be easy, guys. Straight away accessing a new location and writing the data is far easier than accessing multiple storage locations and incorporating the data, right? So I can say for write operations, row storage is a preferred storage. Okay, and for handling read operations, column storage is the preferred one. I repeat, for this one, row storage, for write operations, row store is the preferred choice of database. Okay, for read operations, column store is the preferred choice. Means for OLTP systems, row store is a preferred database choice, and for OLAP systems like BI. So column store is the preferred. Clear everyone? Clear so far? I'm just coming with a very simple example so that you understand. So these are the two types of operations we do have. Okay, two types of storage.
Sir, Hana, hello.
Yeah.
Can Hana have both row and column storage, like only columns?
So now when it comes to SAP HANA, okay guys, HANA can handle both row and column store. It can handle both. Means when you're creating any table in HANA, so you have the option to choose between a row store table and column store table. But always preferred is column store table. We always try to create column store tables. The preferred is always a column store table. So then you can ask me a question: if you create a column store table, yeah, fine. It will give you it will give you optimized performance for read operations, fine. But what about write operations? What about the OLTP? Okay, you cannot ignore the business, right? Okay, so generally, guys, every column store table in SAP HANA, you take any column store table in SAP HANA, it has got two storage locations. You take any database table, any column store table, not row store table, it has got two storage locations. One is delta storage location, and second one is like a main storage location. Delta store contains it has a row store, and main has a column store. Okay.
Satya, you mean like main will contain metadata of the table and delta is like records, no?
No, both will contain the data. I'll discuss.
Okay.
Generally, if you create any table, it will be created with two storage locations, delta and main storage locations. Okay, delta storage location. Okay, if you write any data into the table, data will be always written into the delta storage. Okay, so data will be always written into a delta storage. Suppose some 5 transactions were created, so all the 5 transaction data will be written into the delta storage. So delta storage is a row store, so that write operations will be pretty quick because we are writing into a row store. It will be obviously quick. And this table, okay, so this table has got a okay. So now every column store table has got a concept of delta merge. Okay, so this delta merge is a periodic mechanism. It's not a continuous process. It is a periodic mechanism, runs every 3 to 6 hours, depends on the time company. Okay, so this will actually migrate the data from your row store, means from your delta storage location to the main storage location. Again, say delta merge is a periodic mechanism. Okay, delta merge is a periodic mechanism used to migrate data from delta from a delta store, means which is like a row. I'll show you guys once I start creating the tables. I'll show you clearly. Okay, so this delta merge is like a periodic mechanism. So these are used to migrate the data from a delta storage location to the main storage locations. Okay, so this will simply get you the data from delta to the main storage location. So once the delta merge is successful, there is no data in the delta, and the data will be deleted from delta. there is no point of maintaining same copies at two locations, right? It means we write into the delta, which is a row store. So obviously the write operation will be quick because you're writing into a row store, and using the delta merge, we merge the data and we migrate the data from delta storage location to the main storage location. And this happens, this is not a continuous process actually. This happens every 3 hours or 6 hours. The company, when they're installing SAP HANA, so they'll set this time frame. Okay, so if the data volumes are high in the tables, like a banking company or insurance company or a retail company, if data volumes are high, the time frame will be less 3 hours. If it is like some oil and gas company, or if it is something like pharmaceutical company where the data volumes are less, the data will be so the time frame will be like 6 hours. And over a period of time, so this delta merge happens, and it will simply get you the data from delta storage location to the main storage location. Okay, yeah. And the read operation happens on both main and delta storage locations. I repeat, the read. Okay, whatever the read operation happens. Okay, if you're reading any data from this table, it will access data from both main and delta storage locations. The reason is delta merge is not a continuous process, right? If you read only from the main storage location, what happens? You lose out the recent records which were present only in the delta. Okay, but though we reading data from both main and delta storage locations, guys, more than 99% of the data will be present, will be coming from main storage locations. Years and years of data will be stored in the main storage location only. Only the last 3 hours data, only the last 3 hours, only the transactions posted in last 3 hours or last 4 hours, you will find in the delta storage. Means hardly you see 100 to 200 records in the delta storage, whereas lakhs of records will be present in the main storage. So though we read data from both main and delta storage locations, because finally you are accumulating the data here, right? Though we are writing into delta, but using the merge, we finally accumulating into main, which is a column store. So though we read data from both main and column store, so more than 99% of the data we are reading from main storage, which happens to be a column store. Okay, so obviously it gives you high performance. Okay, because we are reading from a column store. Right, system.
Sir,
Minute, Santosh.
okay, sir.
Right. See here, so generally we write into delta, finally merge it into main. So final storage always happens at a main storage, which is a column store, and read operation can access data from both main and delta. So that whatever, whenever you read the data from a table, you'll see all the data present in the table. If you read only from main access, you might lose out the recent data. Okay, because delta merge is not a continuous process, it's a periodic mechanism. So as we read from both main and delta, but though we're reading from both main and delta, the maximum chunk of data comes from a main storage location, which happens to be a column store. So it gives you optimized performance for read operations also. So this table gives you an optimized performance for both write and read operations by writing the data into row and reading data from column. Okay. As we are finally
Sir,
storing the data in a main storage, just wait. So as we are finally storing the data in a main storage, which happens to be a column store, okay, which happens to be a column store. So that's why we call this table as a column store table. Okay. So as we are finally storing in column, it means we write into row and finally store in column. So that's why we call these tables as a column store tables. Okay, guys. So this is how HANA gives you optimized performance for both read, write, and read operations. Okay, and this is one of the major factors why all the companies migrated their BW systems onto HANA database because of this performance booster. Okay, and this is the reason why SAP HANA is a huge hit in the analytics market. Okay, it gives you an extra improvement in the reading performance, means OLAP performance, without having any impact on the writing performance, which is nothing but a OLTP performance. Right? Yes, Santosh, go ahead now.
So write operation always will be in row, right? That means it is fixed.
This is the architecture. This is how the database is designed.
Okay, okay.
Okay, clear, guys? The columns to table. How we get the optimized performance? This table. Others?
Yes, sir, clear for me.
Clear, okay.
Clear, Satya.
Padma, you there? I cannot hear you.
I'm there.
Okay, okay. Guys, just make a small snapshot of this.
You're going to share this recording, right? I missed it in the beginning.
Yeah, I'm gonna share it. I'll upload it in the drive today. So this is how the storage happens in HANA, and you get a lot of questions on delta merge, guys. Generally, Padma, generally, if you do the certification, we'll get questions from delta merge. What exactly this delta merge works? So this is the major usage of a delta merge. It's a periodic mechanism, so that's used to get data from delta to the main storage locations. And general periodicity is, so that differs from company to company. It's generally between 3 to 6 hours, and this is at a product level, means you cannot differ this from table to table. When you install HANA, so we have to maintain this. Okay, we cannot have two different periodicity for different tables. Okay, it depends on the company. So banking companies where their server configuration is high, banking, and retail companies where data volumes are too high, so they go with a low periodicity like 3 hours, because in within 3 hours they get a lot of transactions. Whereas some companies like suppose I have some infrastructure company or some oil and gas firm, so where the data volumes are somewhat less, so they go with the higher, because they don't need a heavy server. If the periodicity is for 6 hours, you don't need a heavy server. You can reduce some infrastructure cost. Okay, so that is how your delta merge work. Okay, and this is how HANA tables gives us the optimized performance for both read and write operations. Okay, so please copy this part. This one. I'm just giving you a couple of minutes. Please copy. Guys done?
Yes, sir.
Okay.
Yes.
So this is about Swan. So now let's focus on this massive parallel processing. So there is one more concept for today. This is a very short one. This is somewhat like a hardware stuff. So generally, parallel processing is a common concept everywhere. You find in all the databases. Simple. I'll just give a simple example. For suppose you have a table like this. Okay. So generally, if you go to the HANA system runs on 8 cores in general. Okay, it's like a not 8 cores. It runs on 8 blades. I'm sorry, blades. One HANA server operates on 8 blades, and each blade has got something like 8 CPUs. Each blade means total 64 CPUs under one HANA server. And each CPU is equipped with almost octa to 12 core processor. Depends. And some companies might have multiple HANA servers also. This is configuration of one HANA server. So generally means HANA, if we go to the HANA system, it is like 64 into 8, something like 640 minus 128. So 512 to 768 core processor system. Okay, so that's your HANA. So this is the processor of your HANA. Okay, so 512 to 768 core processor system. Okay. So generally, when you go with an Oracle databases, guys, they are like 128 to 256 core processors majorly. Okay, so it's like a 512 to 768 core processor, so which is very high processor when it comes to Oracle. So having a more processor, having like a heavy processor, what happens is you'll have more cores available. Okay, so to perform any activity. Okay, I'll give you a simple example. For suppose you just need to read the data from this table. So if you have 3 cores available, one core will read data from country storage table, one core will read data from product storage, and one core will read data from sales. So means if you have one core available, it has to read data from all the 3 storage locations. If you have 3 cores available, data will be read from, so each and independent cores will read data from single storage locations. Okay, so this concept we call it as parallel processing, guys. So if you have any activity, if you have any query, if you run any query on HANA, so this query will be divided into a lot of subqueries or subtasks, and these all subtasks will be executed in parallel, so which will reduce your processing time. Okay, so that's the reason, guys. Generally, if you buy out any high processor phone or high processor laptop, so your operations will be quick, because if you so any query will be divided into a lot of subqueries, and these all subqueries will be executed in parallel, so leading to low processing time. So we call this concept as parallel processing. And this parallel processing is very heavy in SAP HANA. When you compare with other databases, this parallel processing is too high in SAP HANA. So that what happens is here multiple users can work on the system without impacting the performance of the system. Even if a user is running some 10 jobs, other user is running some 20 jobs, so there is no impact on the system. So a heavy number of users can work on the system parallel without impacting the performance of a system. Okay, so it can take a heavy load because of a high processor systems. So this parallel processing is very huge in SAP HANA, so that's the reason we call it as massive parallel processing. Okay, this is one of the major features why SAP HANA is so quick. Okay, parallel processing is a common concept. You find it everywhere in all the databases, but that parallel processing is high in SAP HANA. Means your company no need to use multiple servers to maintain it, and within one server you're getting 768 core processor. Means so generally in Oracle, to get this level of core processor, you need at least 2 to 3 servers. You have to maintain 2 to 3 servers, heavy infrastructure needed, but you get okay heavy processor in a single HANA server. Okay, that's the reason why this is one of the reasons why HANA server is a bit expensive when you compare with other servers. Okay, so this is some one more concept of SAP HANA. So why SAP HANA is so quick? So we discussed about in-memory database. Okay, data getting stored in the RAM. So yesterday not yesterday, sorry, on the Friday session, we focused extensively on two-tier architecture. Okay, so today we focus majorly on massive parallel processing and columnar storage.
Sir,
Yes.
sir, each column will be stored in each core.
Core is a work processing. Storage is different, processor is different, please.
I mean, when
Okay.
each task is like.
See, one core can work on one task or one subtask.
Okay.
Core is like a
So,
work
sir,
process.
but if you want to fetch a record, it has to see all the columns, or it takes more time, no, sir? Actually.
Yeah, so multiple cores will work on multiple columns.
Okay.
Okay. Right. So these are the two things we thought of plan to cover today. So I stop here for today. So in the next class, what we do is, so auto compression and auto partitioning I'll discuss as part of HANA database sessions. So we will log into the HANA studio tomorrow. We log into the HANA system and we'll start working on the HANA system straight away. Okay. So we will log into the HANA studio. We'll start creating the tables in the HANA studio and we'll start with the database concepts initially for the 2-3 days. We'll focus on database concepts and then we move into the extraction concepts like SLD, BODS, etc. Okay. So tomorrow it's
Okay,
like
sir.
a practical. The hands-on will start from tomorrow. Okay. So I stop here. Thank you all. Have a nice day. Thank you so much. We'll meet tomorrow at same time, 7 p.m.